Cool. Okay. And the event is starting. I'll go back into talking mode. Okay, hello, YouTube friends, and sorry about that. I forgot to actually start the event, so it was only going to Twitch at the start. In my defense, this is my first stream back after taking some time away, so just my brain is a little off. But today we are poking around inside of the Spark streaming partitioning and its impact on key order. Friend of a friend had a question about this, so let's go bring up that question. And so it's they want to repartition the data coming in from Kafka, but they're worried about the impact on the message order. And so that is a thing that we can investigate for them. Yay!
On key order.
Yeah, there we go. Okay, and I have the YouTube chat window up here, so I can take a look at any questions folks have. And so they want to call data frame repartition, and they think it uses the hash partitioner, and when they do it, they get the order of messages that they want, but they're not sure if it's guaranteed or not. It could just be a coincidence. So we're going to go ahead and poke around in the code. And since I don't really know this code super well, it's going to take me a little bit longer. But my hope is that by doing this, you can see how I figure out things that I don't know what the fuck I'm doing. And maybe that will be useful for you. Or, I mean, at the very least, maybe you will feel less bad when you get lost in the Spark code. So dataset.scala has a repartition by expression. If we look at that, the prepare post shuffle RDD, although this is weird, this would, new shuffled row RDD. I'm not, oh yeah, this is going to operate on a per batch basis, so that should be fine. So new shuffled row RDD. So right, what we did is we looked up here. It makes a with type planned repartition by expression. Then I found the places where repartition by expression was used. It ends up making this shuffle exchange exec when it goes to execute it. And then we want to go ahead and look at shuffled row RDD and see how this is implemented. So, yeah, okay. Parent partitioner, partition start indices, coalesce partitioner, yeah. So, presumably this isn't going to be a coalesce partitioner. This is a specialized version of Org Apache Spark RDD, shuffled RDD, that's optimized for shuffling rows instead of Java key value pairs. Note that something like this should eventually be implemented in Spark Core, but it's blocked by some re-implementation. Okay, so this is interesting to note. It means that whatever answer we find might change when this gets re-implemented. Okay. So, interesting. Okay. Shuffled. So, the range of the pre-shuffle partitions. Yeah. Okay. This is interesting, but also a little weird. Okay. Is this extends RDD of internal row with dependency RDD context? Yeah, no. That's pre-shuffle partitions, yeah. Partition start indices. This is our partitioner. Our dependencies is just our input. Our partitioner is sum for this, yeah. And this is get partition. It's okay. So the coalesce partitioner that we use, partition mapping. Right. So let's look. Partition start indices, indices of the partitions in the parent. That should create new partitions in the child. Oh, but this would only partition down. Interesting. So this partitioner is only for coalesce, and shuffled row RDD partitioner looks like it will only coalesce because its partitioner is always a coalesce partitioner. So that's confusing. I'm confused. Okay, but that's alright. Let's go back to shuffle exchange exec. Shuffled row RDD. Okay. So this is new partitioning is of type partitioning. Let's go. Yeah. Okay. Yeah. So this is not necessarily gonna have to go down. Okay. So do prepare coordinator. Serialize. So let's see, where is coordinator come from? So this extends exchange. Prepare shuffle dependency. This is the post shuffle RDD. Okay. So where is coordinator defined? Okay, optional exchange coordinator. That's fine. So then our prepare shuffle dependency def prepare shuffle dependency. Okay, there we go. This is more or less what we want. So yeah, this uses the round robin partitioner is just a hash partitioner. I don't know why we made round robin partitioning. Okay, whatever. Separate range partitioner, ordering attributes. Okay, so these are all just RDD partitioners. So we can more or less go back to the RDD partitioning logic to answer the questions about how this is going to behave, I think. Yeah, So let's go take a look at rdd.scala. Probably actually pair rdd.scala. Yeah. Yeah, okay, actually, let's go take a look at shuffled rdd.scala. I want something like this, but that's... Combine by key with class tag. Key by? Is there a key by? Repartition. Is that defined in rdd.scala? Okay, yeah, it just calls coalesce with shuffle equals true. Def coalesce, partitions, shuffle. Distributed partitioning. Okay. And then we coalesce. We make a coalesce RDD over top of the shuffled RDD. Map partitions with internal index. Is order sensitive? Map partitions with index internal. New hash partitioner, num partitions. What is map partitions with index internal? I don't remember that. Map partitions with index internal. Okay, it's a private function, so I don't remember it. Oh, interesting. Yeah. Preserves partitioning. Yeah. So... yeah. So the function that we give is distributed param index. Okay, yeah, so this is what we use to semi-randomly do this, right? So we... Okay, yeah, and then hash code of the key will just be the key itself. The hash partitioner will mod it with the number of total partitions. Interesting. So if two elements are next to each other but have the same key, I don't think, from what I'm seeing, it doesn't look like we're going to guarantee order necessarily. But if sort within partitions. Okay, so let's go back to the question. Well, keeping the messages ordered per key. So I tried to solve this by using dataset.scala. Wait, not totally. Okay. Sort within partitions. So they're saying that sort within partitions does not appear to be supported on a streaming data frame without aggregations, which is certainly interesting and not at all documented. If that's true, so let's go ahead. Sort within partitions, Spark streaming. Yeah, why would this not work? Yeah. So the question is, if we call sort on a known streaming column, if we call sort on a dataset with a known partitioner, will it change the partitioner? Because that could be another way of also having order. Def sort internal. Well, like the guarantees about ordering during sorting. I'd have to poke at the shuffle service some more to understand that. I don't think we make a lot of guarantees, right? Like we can poke at the implementation and figure that out, but I don't think, like, it doesn't look like we've guaranteed anywhere that a particular order will be maintained of the elements during a shuffle operation. Although here, this is weird. Yeah. So I'm trying to. Yeah, we're not really guaranteeing much here. So we can't make a guarantee per se, but let's go and take a look at how sort is implemented. Because maybe, although that would be confusing, why sort within partition is not implemented in streaming. But let's go take a look at sort inside of SQL. So let's see what we can say here. I'm going to make the text size a little bit smaller because I don't do a great job. Is it a stable sort? Shuffle, exchange, exec. Sort. Sure requirements. Sort exec. Let's go take a look at sort exec and see if there's something interesting in here. So if global is set to true, shuffling the data first if necessary. So the question is, if global order distribution required child distribution. What about so it seems like a thing that we could do that would solve this problem is repartition with a sort, repartition by range. So let's go ahead. I have an idea. Okay. Although, okay. Let's go take a look at distribution suite. Distribution suite.scala. Distribution suite.scala inside of Catalyst. Okay, ordered distribution. So, okay. Single partition, ordered distribution, hash partitioning, range partitioning is the output. Range partitioning can satisfy ordered distribution if and only if its ordering is at prefix. Okay. So, what we could do to sort of solve this problem is have a range partitioner. So let's go ahead and let's start writing up this answer, or a possible answer. So it's been a while since I poked at the streaming code base, but I don't think we make any promises about stable sort during repartition, and there's notes in there about how some of these components should be rewritten into core. So even if we did have stable sort, I wouldn't depend on it unless it was in the docs as a promise. Implementation details can and will change. One possible solution would be, rather than using a hash partitioner, use a range partitioner of the primary key you care about with the second attribute you want to keep in order, although you could get a split on the primary key that way between partitions. Yeah, it's possible in the docs though. So yeah. Then when you can apply a global sort, which, if it matches, the problem is the global sort, now that I think about this, spark, sort, spark, structured streaming, sort. I wanna sort. Yeah, the problem is that only works. One possible I thought of initially, but requires complete output mode. That being said, interesting. That being said, it seems like yeah. Okay, another way that we can solve this would be a custom UDAF. A kind of ugly approach that would work would be to partition first, then do a map, then do a group by plus custom UDAF, which ensures the order within the partition. Would be to first add partition indexes to the elements, then repartition. This is a little ugly, but doesn't depend too much on implementation details. Continuous mode does, okay, yeah, okay, so the first thing that I thought of here, this isn't going to work because we don't support global sort, except in the event of a full output, and the person doesn't want a full output, they they want to do incremental outputs. So poking around in here, while interesting, doesn't really help us. Another thing is we could probably support sort within partitions in streaming in partial output mode in oh, group I key F. Kind of ugly. Damn it. Also require complete output mode. Because we have an aggregation. Although, window, would work. You'd do the aggregate on a window with no delay. Let's go. I'm gonna check some windowing things really quickly. Window operations. Yeah. Yeah, so I think if we do it with no on a window This is ugly. I don't like this approach. But it would kind of work. That being said, I think the most reasonable option This is that being said, while we don't support sort operations on append or update outputs for fairly clear reasons, we don't support global sort operations. It seems like it might be reasonable to relax this and support sorting within partitions. For append/update output. Sorting within partitions, non-global, but that might will require a code change. You can take that discussion to the dev at list. I want to go ahead and see if there's any JIRAs about this, because there might be, right? That might be my JIRA login. Ah, cool. Spark, streaming, sort. Oh, okay, cool. That's a friend. So this actually seems like a pretty good place for us to break today. We can totally do these shuffles. I think we just don't have them implemented in streaming mode for pretty clear reasons, and we should take this conversation over to the dev list. And there's some janky solutions that sort of work, and we'll try and fix those. I'll do some more streaming tomorrow, and on Friday I'll get back to my regular weekly code reviews, and I hope you'll join me then. Thank you.